Okay, here's our second example for average pressure loss method. We have CPVC as the material this time, and we've checked the manufacturer and they're going to allow us to use 3 meters per second for this installation. PRV is set to 550, that's the maximum permitted to a fixture. Elevation loss above the PRV, so after that 550 we have 6 meters of head loss. We have a backflow preventer now. We're going to lose 35 kPa. We've got this backflow preventer after the PRV. Developed length 52 meters. We'll use that to calculate our equivalent length. And then we've got our specifications for all the fixtures. This is an installation where there are 16 suites. One suite is shown, and then the distribution piping here, G and H, will supply the remaining 15 suites. They're all going to be the same load. These 4 hose bibs are, let's say, allocated to a parkade or something where there's public access. So they're all 3/4 hose bibs. We're going to give those 6 each because we're going to call those public, but the rest of the fixtures will all be for the occupants of the suites, and those will get 100% private loads. Okay, so just to verify we can use this method, we'll do the calculation. Here's our adjusted pressure that we're able to calculate at the entry to the building. This is all from the specifications given on the drawing. And we carry that down to here. We're going to deduct a little bit because we have so we got our 700. We have a PRV set to 550. Plus we're going to lose 35 kPa due to the backflow preventer. So we're going to deduct 185 there. 6 meters was the height, so 6 meters times 10 kPa per meter, sorry, will give us the 60 kPa deduction there, and the minimum 105 kPa is a standard design number. So 350 is what we get left over, and we carry that down here, divide it into the equivalent length. Again, that's developed length, which is 52 meters, I believe, times 1.5 to represent some fittings in the system as well. So we come up with 4.49 kPa per meter available. That exceeds the minimum 2.6 kPa per meter that's required. So we can use the method, and we're going to look at the loads now for all the fixtures. So public hose bib, 6 fixture units. These are all table 2632A. Lavatory, 8.3 liters per minute. These are all in the suites, so we're going to go with private loads, that's 0.7. Flush tank, 2.2. Shower, 1.4. Bathtub is a 1/2 inch rough in, so that's 1.4. Kitchen sink, standard type, 1.4. And 3 kilogram capacity hose washer is 1.4 as well. Again, one more time, we're just going to give those hose bibs a public load. On the table, A26312F, we're going to be using the 3 meter per second column. So we use that for hot and cold, because with plastics, typically the velocities will be the same for different temperatures. And then we can start calculating some of the loads for this system and all the distribution piping. So bathtubs, we said were 1.4 each, hot and cold. The flush tank was 2.2, lav 0.7, clothes washer 1.4. Another lav over here. We got another washroom in this suite, flush tank, and another shower here, or shower here I should say. Kitchen sink, 1.4 each. So for each suite we have hot, a total of 7, and cold, a total of 11.4 fixture units. So we use that as we calculate these remaining suites. So if these 2 distribution lines, these 2 distribution mains head to those other 15 suites, the hot would be 15 suites times 7 per suite, 105. And the cold would be 15 suites times 11.4, 171. H, we could say, is 105, and G we can say is 171. All of these will be at a 3 meter per second velocity. Okay, and then we can look at some of the remaining loads here. These hose bibs we said were 6 each. Got 4 of those, so that's 24 for M. couple of supply pipes here. Let's start alphabetically. We've got A is the supply line for the shower. 1.4 is the load, and it's sized as a supply pipe directly from table 2632A at 1/2 inch. B is distribution though, as it supplies more than one fixture. We're supplying the water closet and shower on that cold line B. Total of 3.6 fixture units. And looking at the table for 3.6 fixture units, we can use 1/2 inch up to 8 fixture units. So 1/2 inch for B. C is a supply line to the clothes washer, 1.4 fixture units. Table 2632A, let's say 1/2 inch for minimum supply. D is a minimum supply. It's a hot line, 1.4 fixture units. For a kitchen sink, same table, 2632A, 1/2 inch. So these are all supply pipes, these three here. E is distribution. Total on E is 4.3 fixture units. Again, we set up to 8 fixture units. We could use 1/2 inch for distribution at 3 meters per second. F is 2.1 fixture units, 1/2 inch. Okay, and then we get to G, we said was 171 fixture units. Looking at the table for average pressure loss sizing, 171 fixture units is 2 inch, because we're going to exceed what 1.5 inch would allow. But we don't exceed what 2 inch allows at 337 fixture units. So for G, 2 inch. H is 105 fixture units. So for 105 fixture units, we exceed what 1.25 inch allows, but we're okay to use 1.5 inch for H. I is the total hot leaving the tank. So for the total hot in these systems, we had the 105 to the 15 suites plus another 7 for the 16th suite. So that's 112 is the total load at the tank for all the hot fixtures. So we had 16 showers, 16 bathtubs, 16 clothes washers and kitchen sinks, and 32 labs for a total of 112 fixture units. So I is 112. That means J is 112. And for both of those, 112 fixture units, we can use 1.5 inch. 1.5 for I and J. Now K is all the cold for 16 suites, 182.4. So 182.4 for K. Looking at the table, that'd be 2 inch. For K. L is immediately upstream of the tank, so we're going to take the load of the hot water tank, which is 112, and we're going to add in all the cold downstream of that point, which is 2 water closets per suite, 16 suites. So that's 32 water closets at 2.2 each, which is 70.4. So our total for L is 182.4 as well, 2 inch. M we gave a load to, but haven't sized it yet, so we'll look at the distribution table. And according to the table, we can use 1 inch. 1 inch CPVC for that. And then N is our total. The only difference we've added in between L and N is the 24 fixed units from the hose bibs of cold. So our total for N is 206. And if we look that up on the table, it's 2 inch.